We're going to continue 1.6 by modeling some real world situations with these piecewise functions. So in this situation, feel free to pause, read through it. What's going on here is you're ordering certain amounts of jerseys and you kind of get into a different bracket depending on how many you're ordering. So sometimes it pays off to order more. Like if you can see here, if I order like 100 jerseys, it'd be cheaper at this price here versus these other prices. So sometimes ordering more gives you a discount. In this case, we just kind of fill in what's missing. So we know it's 88 per jersey, so 88 times X when it's between 0 and 5 jerseys. Okay, obviously 0, you're not going to pay anything. 0 times 88 is 0. So you can put an equal to here. It wouldn't really matter. You'd still pay 0 either way. So you could argue which way you want to go on that. Let's see, it's 75 per jersey, so 75x if it's between 5 to 11. Now, here's where, I might even argue you can write it a different way. I can't order like 5.5 jerseys or 5.9 jerseys, so you could just write it this way, if I order between 0 and 5. And the next thing I could order is between 6 and 11. So it's up to you. This is just kind of the way the textbook formatted it, but I could also see that this would be an acceptable way to fill these in as well, since they can't have a decimal jersey. This way is basically just implying, hey, everything bigger than 5 but not equal to, so obviously we'd have to go to 6 jerseys and stuff like that. Same thing here, 65 per jersey if it's between 11 and 29, so basically 12 to 29 jerseys. Again, I might just write it this way, but the textbook wrote it that way. And then it's $56 for anything beyond 29 jerseys. So once you get to 30, it'd be at this bracket here. So what would it cost to purchase this? We can evaluate these different functions. We want to purchase 11 jerseys. Well, I just got to find the right category. There's two 11s if you look at this, but really this is the only one that has equal to 11. So I know it's $75 per jersey. So 75 times 11 jerseys would be $825. What would it cost to purchase 25? Well, I just see where that fits. Okay, 25 is between 11 and 29, so it's this function. So it's 65 times 25, because we had to pay for each jersey. So multiply that, you get $1,625. They can also write it this way, evaluate F29. So they're basically saying X is 29. So be careful here, there are two 29s, but this one is not equal to. If I'm paying for 29 jerseys, I'm still actually in this bracket here, this category. So 65 times 29 would be $1,885. Feel free to pause and read through the situation. With the purchasing box as a tile, we do need to make the actual entire function. We can see it's $48 for each box of tiles, so I did 48x, 48 for each one. You can also have some constant numbers in here sometimes too, but this one is $40 per box. In this case, I chose to do 0 less than or equal to x. You could also do 0 less than x. I doubt you're buying 0 boxes. Either way, you pay 0 anyways. But there you go. So anything that's 3 or fewer, and then 45 per box, so 45x when it's between 4 and 8, 42 when it's between 9 and 19, and then 38 per box of tile if it's more than 19. So once we get beyond, like once we get to 20 boxes and things like that. Again, you could probably write this in other ways. This was the easiest way I did it. You could do like the 3 less than x, less than or equal to 8. And this is just how I wrote it. I thought it would be easy enough to do this. Because I can't, in my opinion, buy a partial box. I can't buy 3.2 boxes. Okay. So what's the cost of purchasing 5 boxes of tiles? So just find the right category. 5 between 4 and 8. So it'd be this category here. So 45 times 5 boxes, so $225. And then we're going to buy 19. Just be careful. There are two 19s here. But remember, this is everything beyond 19, not equal to. So I'd use this category. So 42 times 19. So $798. What we can also do is a step function, so to graph these here. So with a step function, what you have here is a series of kind of steps. It's a discontinuous function here because they're not all connected and can't draw it without lifting your pencil off the paper. So we got a whole bunch of different little constant functions. The domain is going to be an interval of numbers. The range will only be a discrete set of numbers. So like in this case, the range would only be, let's say, it looks like I use -3 or -1 or +3. I only use certain numbers. I don't use everything in between those values. Okay, let's give this a shot. Go to the next page here. There we go. So we're looking at, did I skip a page? No. Okay, cool. So we're looking at this cost of mailing a letter. Now they said draw a table and draw a graph. You don't necessarily need a table to draw the graph, but here's what it would be. We have different weights and we have different costs depending on the weight. And it literally is how it works. I don't know if it's exactly these costs, but it is something like this. If it's between 0 to 1 ounces, then it's going to be 47 cents. If it's between 1 to 2 ounces, so up to 2 ounces, then it's 68 cents, and so on. Just read through the situation. So not over 3 ounces, so between 2 to 3, it's now 89 cents. And between 3 and I have no idea how they got 3.54 ounces, but there you go. That's their cutoff is $1.10. So if you actually graph that, what's happening here is, so obviously if it's zero, you pay zero, so that we kind of start off with an open circle here. If it's zero weight, I'm not going to pay 0.47. It's got to weigh probably at least 0.1 ounces or something. So, but from there, anything between 0 to 1, it's going to be 47 cents. And at 1, it's a closed circle because I do include that point. Once I get to 1.1, it's now in a new category. So 1.1 would now be in the next category. Between 1 to 2, it's now 68 cents. And between 2 and 3, it now costs 89 cents. And then once we get between 3 and 3.54, it's $1.10. The domain of this would be 0 through 3.54. So we actually use all these x values. So even though it like starts and stops, we use, notice open circle there at 0, or open bracket or open parentheses there, till 1. And then, but it keeps going. I then use, through 2, 3, 4, up to 3.54. But the range, I have to use these specific values. I can't say it's 0.47 all the way to 110. I don't use all the numbers. I only use 0.47, 0.68, 0.89, and 1.1. We can try that one more time. This time they actually do have the table filled in. Depending on how long they work, it looks like how many hours, there's different costs. So between 0 to 5, it's 500. Again, notice 0 has, all this side here has open circles, has not equal to. So we start off with a open circle, then we get to a closed circle. So between 0 to 5 hours, it's 500. 1400, so we're right below 1500 there. So between 5 to 15 hours, it's one rate. Then between 15 hours to 30 hours, it's going to be $2,500. And then lastly, between 30, then all the way to 50, our graph just fits it to 50, would be 4,000. The domain is from 0 to 50 because we actually use everything between 0 to 50, not including 0. That's why it's in parentheses. Our range is those specific y values only, 500, 1,400, 2,500, 4,000.